Okay, hello everyone. In our last video, we looked at the laws used in indices. So in this video, we're going to be looking at some of the simple calculations we can find in indices. So starting with the first question, we have 2a times 3a squared. So first we'll multiply the digits 2 times 3 times, then since we have a common base here, we'll just copy the base a. And then in the laws of indices, whenever we are told to multiply in indices, since they have the same base, we are to add the powers. So have a to the power of 1 plus 2, and that will give us 6a to the power of 3. Moving over to the next question, we have 2a times, you see that we have a square outside the bracket, so all we need to do is to distribute the square to both 3 and a. So we have 3 squared, a squared. So this will give us 2a times 3 squared is 9, and have a squared. So just like we did before, I have 2 times 9 times, we have a common base a, we add the powers 1 plus 2, which will give us 18a to the power of 3. Moving over to the third question, you see that we have a fractional index. Now this 2 below it, the denominator, signifies the root of the term given to you. And since we have 2 as the denominator here, which means we have to find the square root of 4, or we say the second root, which is equal to square root of 4, and the square root of 4 is 2. Then going over to this next one, the denominator here is 3, so which means we have to find the third root of 27. The third root of 27. And the third root of 27 is simply a number that will multiply itself 3 times to give us 27, and that number is definitely 3, because 3 times 3 times 3 is 27. Then to this, we still have the denominator as 3, so we take the third root of 125. So again, we look for a number that will multiply itself 3 times to give us 125, and that number is 5. So the next one, we have 2 to the power of negative 2. So we have a negative index, and according to the law of indices, in order to change this negative index to positive, you need to take the inverse of the value, and the inverse will definitely be 1 over 2 to the power of 2. So I've changed the index from negative to positive, and then 1 over 2 squared is 4. For the next one, we still apply the same thing. We have a negative index, so we take the inverse, which is 1 over 3 cube, and that is 1 over 3 cube is 27. The same thing applies here, a negative index, so we take 1 over 9 to the power of 1 over 2. Just like we said before, that index 1 over 2 signifies square root, so I'll take the square root of 9, and the square root of 9 is what? 3. Then moving over to the ninth question, we'll have a fractional index here again, but this time around we're going to separate the main root from the power. And how do we do that? I can rewrite this as 8 to the power of 1 over 3 bracket squared. It's still the same thing, because 2 times 1 over 3 is still 2 over 3. Then this third root, we take the third root of 8 half squared. So the third root of 8 should be a number that will multiply itself 3 times to give us 8, and that number is 2. We indicate our square, and 2 square is 4, that is 2 times 2. Then over to this last question, we have a fractional index but is negative. So in order to change to positive, we take the inverse of it, and the inverse is 27 over 8. 27 goes upwards, 8 goes downwards, and we have index 2 over 3. So since the index is outside the bracket, we have to distribute the index 2 over 3 to both 27 and 8. And by doing so, we have this. Then we separate the main roots from the power, and that will be 27 to the power of 1 over 3 squared over 8 to the power of 1 over 3 squared, equal to, we take third root of 27 indicate r squared, over third root of 8, also indicate r squared. The third root of 27 is 3, put r squared. The third root of 8 is 2, we put r squared. 3 squared is 9, 4 squared is 14, is 4 rather. So my answer is 9 over 4. Or you can decide to put it in mixed fraction as 2 whole number 1 over 4. So we have treated simple calculations in indices. In our next video, we'll look at more complex questions involving indices. So thank you very much for watching, and please make sure you subscribe to my YouTube channel. Thank you very much.